Hello everyone, this is Lord Cucumber. So, one of you suggested that I keep a weekly or daily or whatever, a periodical devlog. I'm gonna do this weekly, I guess. So, but there's been so much progress in the last 3 days, it's kind of hard to condense in a short video, but I'm still going to give it a go without getting too boring. Alright, so as you may or may not know, I'm currently working on a tile-based dungeon crawler with procedurally generated levels. And I've come quite far. Currently I'm working on a tile sensor. Before I get into that, I'm just going to give you a short demo of what things look like if it doesn't crash. Providing it doesn't crash, there we go. So that's what this looks like now. It's all placeholder graphics. The R's, the W's, and the F's are in sequence rock, wall, and floor tiles. They all have different values. If you have a player character in the game, eventually these objects, represented here by R, W, and F, will have options to either not walk or walk on them, access them or not access them, interact with them or not interact with them, if you will. Basically, they're going to form the basis for the level. Now, all of these blocks you're looking at will be connected by hallways, which will also be surrounded by walls. And there will be doors and whatnot, and obviously the graphics are going to change considerably. Also, right now, if I had any way of moving things around, I couldn't because it's locked in the screen. I'm going to write an update method in the near future, which is going to be fairly interesting to update all of these tiles to actually update as we basically move around with whatever character, so that the camera stays on the character and the map basically shifts around him. I'm also going to write something that will ensure that outside of the viewport that we see here, nothing actually gets rendered graphically, because that also takes quite a few resources, especially when you're updating. If I were to move around the map right now, if we were to move south, as in down, and the top layer of these 5 objects would move up, that would take quite a bit of resource from the CPU, and it might eventually cause glitching. So I'm going to sort of include that in the update method. That's the plan, at least. That's in the near future. I'm not sure when exactly, but that's the plan, after I manage to connect these things in a proper way. Anyway, I've got an idea for that, by the way. I'm going to show you what I worked on today, which is... I have to stop it here as well. There we go. Visual Studio has a couple of things that I don't like about it. This is one of them. If you exit a project that you're running or test running or whatever, it keeps running in the background for some reason. I don't know how that works. I could have pressed escape, by the way, but I didn't. Anyway, all these tiles have, as I said, certain attributes. They have a state, if you will. One of those attributes is being accessible or not. Basically, it's a field that says accessibility is true or false. It influences your character if you move around. If you walk into a wall, that you stop walking. Basically, you move forward, and you press forward again, and or whatever button I assign it, and the program will test if the tile in front of you, in the direction that you're moving, north, south, east, west, doesn't matter, is in fact accessible. If not, it's going to stop you right there. It's not going to execute anymore. You can press the button all you want. It's not going to do anything. That's the idea behind that logic. And I've written a little thing that I'd like to call the tile sensor, which I'm going to show you right now. It's a bit technical, but you might be able to follow this if you have a little bit of programming experience. Now, the whole deal is, of course, you have to break things down for the computer. You have to explain all kinds of things to the computer, because it's not going to get anything if you don't. So basically, what I did was I broke the whole process down in my head and took all the elements I already had, certain position elements, for instance, and a list of tiles, which was very hard to access from this position, but we'll get to that. From a different class to another class, it's always a bit of a different thing. It's as you can see, I have quite a few classes here. All of these things are classes. Basically, they're cookie cutters for objects. And if you instance them, you can influence them. You can do whatever you want with them. Instances means basically you take an object and you say, okay, this object is the cookie cutter, and I'm now going to cut the cookie, and I'm going to use the cookie and see how the cookie crumbles, and influence that. So you can sort of say, okay, I need all of these components for my machine, and I'm going to create components custom made for that machine. That's what you're doing when you're using the classes to create objects. So there we go. So this is also an object, the tile sensor. And the tile sensor influences well, one of the things it influences is the way you move around, as I told you earlier. It can basically sense whether or not you can move in a certain direction. And it's doing that already. It's going to have some other options as well. It's not just going to do that. It also has a range option. Basically, it doesn't have to be 1 tile away. It can be 5 tiles away, for that matter. Not sure how I'm going to use that, but I decided to build it in while I was at it. Thinking ahead is part of programming. Believe me, it's an important step. If you want to become a programmer, you have to have like 4 or 5 steps ahead in your head to make it work. And not get into trouble later. So it's a good idea to have a sort of model of what you want. So there we go. So alright, back to how it's structured. The tile sensor obviously has some fields. Fields basically are the shapes that are involved in the cookie cutter, if you will. The distinct necessary requirements to make the shape you want. The whole deal, the whole object. So I decided to go with integers here, basically numbers, representing facing, as in 0 will be north, 1 will be east, 2 will be south, 3 west. That's actually, that's with the clockwise. So there we go. Nice. And range being range in tiles. So every block you just saw in the demonstration is 1 range tile. And of course you have your current position, where you are right now, on which tile you're standing, which has a position in the screen, and you have a target position, which is the position of the tile you're looking at. Now this is tricky, because if you're moving around, your position changes. So this is still from a standstill perspective. I still have to write something to actually get the current position before messing around with the tile sensor. But I'm getting to that once I get to a player character like object that can move around. And then it will be easy to test this, because this is right now untestable. I don't have anything to test it with because I can't move around. Technically, I could write something to do that, but that takes a while and I don't have the time today. I'm just making this video and then it's off to work, actually. So, it has a current position, it has a target position, or something representing the target position. It has a target list. Now this is a trick bit. Basically it has to go into the tile list for the level, sort of reference that and make that into the target list. Otherwise it won't work. It has a target level. That's also important. If I instance a tile sensor basically in my main class, where everything is condensed into one package, I have to pass the level on which this tile sensor will work. So the idea is that the target level will be the currently active level. You can't be in 2 levels at the same time in this game, in most games by the way, But in this game specifically, you can't be in 2 levels at the same time, so this is a reference to the current level. So that it reads the right list, because each level has such a list with tiles. I hope you guys can still sort of follow along here. It's not that difficult, it's all logic. So that's what it does. This is a constructor. Basically, this is what you call when you start the tile sensor or instance the tile sensor for a certain level. It says tile sensor, pass the level. This level is the level. It just has to sort of compare those and set them as 1. And then the target list becomes the target level dot level tile list. Basically, it says, okay, I'll take this, and that will be the reference for this. It's a bit difficult to explain, but it's basically saying, okay, you've labeled this level the target level, and now the target level has all the attributes of the level that you targeted. Good. Complex, a little bit, but it's quite logical if you look at it from the perspective of somebody who's done this before. If not, this might be gibberish to you. I hope you learned something here. All right, so I had one method readily available, basically 2. I decided to get the whole target position thing in a separate method. Why? Because I'm going to use it again. So I actually started writing the check is next tile accessible method first, and then I realized, well, you know, I don't want to write this whole targeting position thing like 6 times if I'm going to add more methods here. I'm just going to do it once and then reference or activate basically the get target position thing inside the methods that I'm going to use. So I only have to write it once. It's good practice for a programmer. Alright, so basically I've made a comment here what it does. This method of the get target position determines the target position at range. And that can be range 1, it can be range 6. It just cannot be range 0, otherwise you're just targeting yourself. Although theoretically you could do that. Alright, actually that might be the key to getting my own position. Didn't realize that, that's actually a pretty good point. Okay, well anyway, doesn't matter. I'm just gonna go through it quickly. Alright, so it has to return a vector2, which is basically a reference point with an X and a Y. And it's called get target position. This is what you use to call it. And between the brackets here become all the stuff we put all the stuff that we need to make this one happen. So basically we say, okay, we need an integer number, a number for the facing. That's going to enter that here. So if we were to do if we were to instance this would become, for instance, I don't know, 0 for north. Range would be 1. And you just have to write the numbers when you instance this. You wouldn't have to do all the other bullshit. And vector2 would require vector2 as a sort of a naming convention, and then between brackets, the X and the Y. Or this could be another reference that I made earlier. You could also do that. You can pass references or actual vectors. So basically that's the current position once we get it. And we say, okay, that's cool. We use that. And we say, okay, from the current position, we're going to go that much in range facing that direction. So that's set up right here. It has to equalize that. Still don't know how you call that, but they have to be the same as the things we mentioned up here. So, alright, so I made a switch, which is sort of an if statement. If you know an if statement says if something is true, then act a certain way. If something is false, then act a certain way. If something compares to something else, that is true, then act a certain way. That's how you do that. The switch statement is something sort of similar, but in this case it says, okay, switch facing, and that's the thing we put in here. So basically it says if facing is a certain value, in between brackets, it will do the following case, and it states, okay, if it's a 0, I'm going to do this. In this case, it's going to take the target position, its y coordinates, and it's going to make that the current position of y minus the constant tile size. Basically, that's a constant I've made, a number I've made that represents one side of one of the tiles, which is in this case 16 pixels, times the range. And depending on what range you took, for instance 1, it will do that times 1, so it will shift the position of the current position. It will go up 16 pixels from the current position and find the target position, and it will return the target position. The same will go for the x and y directions, the alternatives of east, south, and west. So that's it really. And the break here means it breaks out of this small mini loop and then says, okay, what's target position, and gives that back. Which is cool, which is another vector, and it says, okay, then this is the target position. Now you've got that. Now that you have that, hey man, perfect. It's got a value. It used to be empty. It used to be, just this with nothing in it, no value. Now it has a value. So if, for instance, check is next tile accessible calls this thing after passing a range, it says, okay, cool, man, you've passed a range. And I could have just put 1 here, by the way. Anyway, doesn't matter. And yeah, go for it or something. This might actually not be a very good idea. Anyway, I might review that at some point. I might actually make this into a 1, and I might. Alright, basically says, okay, you've got the target position found here via the method I just showed you. Good. Then get the list from the level. Now this is where it becomes very complex. This took me a whole morning. Get the list from the level object. Check the list for the object containing the target position. Okay, so if the list that I'm going to check, basically the level, has the target position, get the tile at the index and retrieve the flag for accessible. So it has to find the level tile in the list and then say, is it accessible or not? That's basically what it's going to do. So here we go. First of all, we have to find the location of the target position in the list. I stored the target positions, basically the tile positions, in a list in the level class right here. Whenever the whole level is built up, it stores that. And so all of those tile positions we saw on screen, all those W's and R's and F's, they all have their own little tag as a tile position. Obviously, otherwise they would be in the same spot in the screen and you wouldn't be able to make them out. So they all have a different coordinate to them. Basically what says, okay, we've got a target position. I'm not sure if this works correctly yet. This is the first time I've actually used the find index in C#, so I'm not sure if it's going to work. I might have to rewrite this. But what it should do is compare the target position we just found from our little trip we took from the current position, and compare it to the tile position, the public tile position, vector2 in the list that we've stored. And then if that's if it's there, once it finds it, it returns the index in the list, basically the location in the list where that target position is stored, or the tile position is stored. It says, okay, it's over there. Fine. In that case, target tile, which is a tile I'm going to temporarily instance here to reference it, is the target list location in list. So basically it says, okay, I'm going to take the tile in the list, I'm going to make this into the target tile, which is cool, you know. And then it says, okay, return target tile accessible. It's going to see with another method in the tile thing whether or not this thing is accessible or not. And that's the whole process of checking if the next tile in front of you is actually accessible to the player. If not, you can move all you want, but you won't be getting there. That's what it's supposed to do. I haven't tested it yet. I will test it as soon as I have something going on screen. But I need like hallways first. I feel like I need to do the hallways. I mean, it looks cool if I run it now, but it's just, I mean, a 5x5 room, I'd be crazy running around there. I need to test a lot of things that require me to actually connect them. So yeah, that's what I did today, this morning. And my goodness, I still have a bit of a headache here from the trip. Now, obviously, there's coders amongst you. And if you see obvious mistakes in this scripting, please tell me. Because there might be. Without ability to test it, it's very difficult to determine. So I would be very appreciative if you were to give me some feedback. Anyway, that's all from me to you today. There's gonna be a gaming video up, I think, this weekend. If I can get myself to do the processing after this week. It's going to be a bit of a rough week. I'm not sure how school's going to go. And I'm going to have an application talk on Friday with one of the customers of my agency and see if it matches. And, well, I'm going to have to wait and see. So it might be a very rough week. I don't know. But I hope to see you all soon. So I hope you enjoyed this video. I hope you understood some of it. I'm very happy doing this in my spare time. Hopefully soon I'll be able to show you guys some results of some progress of what I'm doing here. So hope to see you then. Bye-bye.
Ladies and gentlemen, thank you ever so much for watching. Please consider leaving a like and or comment. And please also subscribe if you haven't done so already. Thank you again. Cheers.